Hi, my name is Matt. My Manchester Code's final project is called Qualpass, which is short for Qualification Passport. The idea for the app came from fellow Manchester Code student Holly. In her day job as manager of a water sports centre, Holly is responsible for hiring freelance coaches and instructors, each of whom has a number of qualifications that need to be recertified periodically. Different people have different qualifications have different recertification periods, freelancers tend to come and go, so it's something of a nightmare to keep track of who's qualified for what and who needs to recertify. Enter Qualpass, the app that takes the pain out of tracking such things. Now you may notice that the slide only has my name on it. That's because the easing of lockdown restrictions for outdoor activities meant that Holly was unfortunately too busy with work to be able to help with the project. I thought it was a pretty good idea, so I decided to crack on with it myself. Like many modern web applications, Qualpass is built with a separate front end and back end, connected only by the API calls that the front end sends to request the data. Front and back end are not connected in any other way. In programming terms, they're said to be loosely coupled. The most obvious advantage of this is that front end can be redesigned, reconfigured, even swapped out for entirely different technologies without disturbing the data managing back end, which is the business end of most applications. Front end and back end can be, and often are, hosted in entirely different places, and that's precisely what I've done here. I deployed the back end to Heroku and the front end to Vercel. Both Heroku and Vercel offer a free tier, which is perfect for developing MVPs like this. You can access the app at the URL that you can see on the slide there. One thing to bear in mind, if you do visit the site, although you're accessing it via Vercel, remember that the data is pulled from Heroku, and on Heroku's free tier, when the app isn't being used, it effectively goes to sleep so that it doesn't consume any resources. When it's first accessed, it takes a few seconds for the server to wake up and for the data to be sent. After the server has woken up, everything works perfectly smoothly without any delays. Now, both Heroku and Vercel connect directly to my GitHub account, making it super easy to deploy the apps directly from there via the command line. Code changes committed to the main branch on GitHub are automatically deployed. For user authentication, I chose to use Google's Firebase. I'll talk a little bit more about that later. And as for the look and feel of the app, I used Figma to plan the layout and design the landing page that you'll see in a moment, because I think it's now time to show you a little bit of how the app works. Okay, here is the app's landing page. Now, on this page, users can sign up for an account. Existing users can click through to sign in, or we can simply continue as a guest, and that's what we're going to do now. And that takes us to the page that lists the workers alphabetically by surname. Here you can search for job types, and if your search term returns no results, you'll get a little message like so. Now let's try something that hopefully should give us some results. There we go, that returns everybody whose job title includes sale. And you can access a user's profile by clicking on the button. So here we see a person's name and their job title, plus the details of this person's qualifications. You can reorder the table by clicking on either of the date columns, so you can order them in ascending or descending order, and any of the qualifications that are about to expire or have already expired are colour-coded accordingly. You can see the key down there to see what it all means. So let's now log in as one of the workers. Okay, since this person, this is the same one we were looking at a moment ago, it has qualifications that are either expired or expiring, we get this alert immediately after logging in, which gives us the relevant details. So if we now click through to the profile, so now that we're logged in, you can see there are a few changes. The main nav bar has changed. The user can navigate directly to their own profile by clicking the Your Profile link, or they can sign out. And the profile page has changed too. Each entry in the table has a delete button, and there's a form available to add new qualifications. And these changes only apply to the logged in user, so if we were to go to another, there we go. So there's no add a qualification form, and there are no delete buttons, so I'll go straight back to Teddy's own profile. As you can see, this user has an expired qualification. So let's add the recertified version. So there we go, then the new version is there down at the bottom, so we might as well now delete the expired one. You don't have to, but you can do it, so there we go. Okay, let's sign out of this user, and I'll tell you a bit about the technologies that I've used to build the app. Looking at the back end first, it made sense to me to use the skills that I'd learned during the backend module of the Manchester Codes course. So the Qualpass backend is built using Node, Express, MySQL and Sequelize. Node is described as a JavaScript runtime environment. So what does that mean? Well, JavaScript was originally developed as a programming language to run in a web browser. But Node enables JavaScript to be used in other environments too. Express is a minimalist JavaScript framework running on Node that I use to create a web server. MySQL is a relational database management system that controls the database in which the app's data is stored. And Sequelize is what's known as an ORM, which is an object relational mapper. It streamlines the communication between Express and the database and means that I don't have to write complicated SQL commands. So let's have a quick look at some of the back-end code. Here you can see one of the models that Sequelize uses to create the database tables. A model can be thought of as a blueprint for an object that has certain attributes. Each object has its own database table with different fields that represent the attributes of that object. So what you can see here is the worker model that creates the worker's database table with fields first name, last name, job, email and ID. As well as the workers table, I have tables for qualifications with fields, just the name and the awarding body, and I have what's known as a joining table called awards, which connects individual workers with qualifications and holds relevant dates for each award. Now, this join table is necessary because each qualification could be held by more than one person, and each person can have more than one qualification. So in database terms, that is a many-to-many relationship. And Sequelize helps to simplify the creation of that relationship. It just takes these 3 lines of code that are highlighted here in order to do that. Look back at the worker model. You note that there's no mention of anybody's password in my database, which brings me on to the thorny subject of user authentication. This is a biggie because of the obvious security implications, and it's something that I was determined to try to tackle, at least in some little way, as part of this project. Now, I settled on Firebase because firstly, Diego gave us an introduction to it in one of our front-end lectures, so it felt a little less intimidating. The documentation is really good, and it's free, or at least it is at this level. There is one problem in that there are so many different ways that you can use Firebase, and to begin with, I went in the wrong direction. I spent a couple of days thinking I had to encrypt passwords myself and generate my own JWTs, but then I discovered the simpler way that I'm using here. To give you a feel for the simple solution that Firebase offers, I will show you some of my front-end code. So here you can see the register component of the React front-end of my app, and specifically the function that takes care of setting up a new user. So once the function is happy that the data is valid and the passwords match, it sends the new user's email and password over to Firebase. Firebase then returns a new user's unique ID, which is passed to the user context within React, and it's also sent to the back end by a POST API request, along with the name and job title, and the worker is inserted into my database. Finally, the new user is redirected to their own profile page. And if I scroll down a bit within this component, you can see the code that actually creates the register form on the app, which we will have a look at now. Here we are back at the app's landing page. Let's quickly sign up a new user. There are some error catching and validation things included here, but I won't deliberately trigger any of it because I think I'm already in trouble with Cursor because my video is too long. Okay, the new account has been set up, the new user is logged in. During that process, behind the scenes, the user's data was sent to Firebase, where the password was encrypted and stored somewhere within Google's systems, so that I don't need to concern myself with those aspects and I can sleep at night. Moving on to the front end, again I wanted to put to use the skills and techniques that I've learned during boot camp. So the Coldpass Frontend is built using React, and the styling is taken care of with styled components. And of course HTML5 and CSS3 featured. They're the fundamental parts of any front-end web application. So now I will just quickly show you the app component that handles how and when other components are displayed using React's built-in router. Here you can see my main app component, and React router enables me to specify the components that a page is composed of dependent on the path or the URL that's requested. I've done my best to make the app responsive across the whole range of screen sizes. And here I'm using Firefox DevTools to demonstrate that. On smaller screens there's a tablet, and that's what it looks like on an iPhone. The main difficulty I had with the responsive aspects of this was with the this qualifications table in the worker profile. Data tables don't handle narrow screens very well at all. See how on an iPad it works fine as a standard table, but when you get to a mobile phone screen, I've changed it so that every element within the table, I've made it display block, and that seems to do the job okay. It could probably be tidied up a bit, but I'm pretty happy with the way it's turned out. Extra things I would add if I had more time. During user sign up, I would include email verification. At the moment, all the app does is checks that the two passwords match. And I would also set up other user types. First of all, for organisations that hire the workers, so that they can add their own workers to their accounts and receive notifications when recertification is approaching. And for admin users who have the ability to add new qualifications to the database. At the moment, that has to be done via an app like Postman, sending a post request direct to the Heroku backend, or using a database admin package like Mysql Workbench. So that's it, my final project. All that remains is to say a huge thank you. As you can see, it's so huge it won't fit properly into its allotted space. Thank you to all the tutors and support staff. You've been immensely supportive throughout. Thank you to my cohort buddies for making it such an enjoyable journey. We've learned a massive amount in a relatively short time, and I've loved every minute of it. But right now, it's beer o'clock. So cheers!